Chapter 10.2 Study Guide and 10.3 Study Guide. A couple of problems here. Lesson 10.2 is on arithmetic sequences and series, and as you can see here, we've got a formula that's highlighted on your study guide. If we're going to use that, that's for arithmetic sequence, and we're going to use that to solve some problems. Like number 1 says, find the 11th term of the arithmetic sequence. Sorry, the 100th term of the arithmetic sequence. So to do this, we put the first term of 1.6 in for A1. We're trying to find the 100th term, so 100 minus 1. And then can you tell that the common difference is that it's going up by 0.7 each time? So now if we use the calculator, that's going to give us the 100th term by typing in 1.6 plus, we get 99 in the parentheses, times the 0.7. That gives us an answer of 70.9. So that's your 100th term of that sequence. Number 2 says find the 28th term of the arithmetic sequence. So again, we'll use the same formula. You can see that your first term is negative 1. We're going to be trying to find the 28th term. And hopefully you can tell that it's going down by 2 each time, so that's your common difference. So your 28th term would be equal to, let's see here, we have negative 1 plus, we'd have 28 minus 1, which is 27, and then the common difference was negative 2, and we get a value of negative 55. That represents the 28th term. Number 3 says find the first term of the arithmetic sequence where the 15th term is 30 and the common difference is 14. So again, I want to use this formula. And what I'm going to do is I'm going to put 30 in, I'm going to put 15 in for n, and I'm going to put 30 in for a sub 15. So a sub 15 is going to equal a sub 1 plus, I'm putting 15 in for n, and you can see that our common difference is 1.4. And now what I can do is I can substitute in for a sub 15. I can put 30 in there. This now allows me to solve for A1. So let's see here. That's going to give me 14 times 1.4. 14 times 1.4 gives us 19.6. So if we've got 30 equals A1 plus 19.6, subtract the 19.6 to both sides, and we would get 20.4 for your first term. Number 4, find the common difference in the arithmetic sequence where the first term is equal to 6 and the 40th term is equal to 142.5. Well, we're going to use the same formula. All right, we're trying to find the common difference here. And since we know that the 40th term is 142, I'm going to put 40 in for n. And if I put 40 in for n, if I put 6 in for the first term, I'm going to get a 39 here. We're trying to find that common difference. But now I can go back and replace this a sub 40 with its value, which is 142.5. So if I subtract 6 to both sides, I get 136.5 equals 39D. And if I take the 136.5 and divide by 39, 136.5 and divide by the 39, we get the 3.5, which represents your common difference. All right, now finding sums. You can see that I've got a formula highlighted right here. That is for an arithmetic series. 3 things you got to know. You got to know how many terms you're adding up. You got to know the first term, and you got to know the last term. So number 1 is an example. Find the 82nd partial sum of the arithmetic series. So you can see the first 3 terms there. Hopefully by those first 3 terms you can see that the common difference is that it's negative 3, going down by 3 each time. Since we're finding the 82nd partial sum, we're We're going to find S sub 82. We're going to put 82 in for n. You can see that the first term is -1, and then we just need to figure out what is your 82nd term. Well, to figure out your 82nd term, I'm going to use the formula to do that. So A sub 82 would be equal to the first term, -1, n minus 1, which would be 81, and then you can see the common difference is -3, and so this would give us -1 plus 81 times -3, and we get -244. So if I put that into the formula right over here, -244, that's going to give me the sum of the first 82 terms. And let's go to the calculator now, and we get, let's see here, 82 divided by 2. And then our first term was -1. And then our 82nd term was -244. And that gives us a total sum of -10,045. That's the sum of the first 82 terms. Number 2, find the sum of the first 25 terms in this series. Well, hopefully you can tell that the common difference is 3. So again, we're going to use the formula. The sum of the first 25 terms would be 25 divided by 2, because n is 25. You can see that the first term is 7. Again, we just got to figure out what that 25th term is. I'm going to do that by putting 25 into the sequence formula. First term is 7. 25 minus 1 is 24, and since your common difference is 3, we get that value 7 plus 24 times 3 gives us a value of 79. So the 25th term is 79. Put that in here, and we'll get the sum of the first 25 terms. Using the formula, 25 divided by 2. And then your first term again was 7, and your nth term was 79. So 7 plus 79. And that gives us 1,075. That's the sum of the first 25 terms. I guess I didn't even pay attention. It looks like it showed us the nth term right there, so I guess I should have paid a little bit more attention, huh? All right, number 3 says find the 53rd partial sum of the arithmetic series. So again, 3 things you got to know is n. You can see that's 53. The first term is 12, and the nth term. We don't have the nth term, but hopefully you can tell that the common difference is 8. So let's find the 53rd term using the formula 12 plus 52 times 8. Okay, 12 plus 52 times 8 gives us 428. So that's my nth term. And so now the sum of the first 53 terms would be 53 divided by 2. First term is 12, and your 53rd term is 428. Let's go up here and grab this a little bit faster maybe. And if we change these values, we got 53 over 2. Our first term was 12, and then 428. And that gives us a total sum of 11,660. And again, that's the sum of the first 53 terms. Number 4 says find the sum of the first 42 terms. And you can see the first term is right here. You can see the last term is right there. So pretty simple using the formula. The sum of the first 42 terms would be 42 divided by 2. 1.5 plus 22. And if we go to the calculator on that, let's change that 53 into a 42. And our first term was 1.5 plus 22. And that gives us a total of 493.5. So that's the sum of the first 42 terms. Okay, moving into problem number 5, this is a sigma notation where you can see that the lower bound is 3, the upper bound is 15, and you got a formula. So if you put 3 into the formula, you get 10. If you put 4 into the formula, you get 13. So hopefully you can tell it's going up by 3 each time. If you put 15 in, you get 46. So that's your last term. Thus, the sum of, let's see here, 15 minus 3 is 12. 12 plus 1 is 13. So the sum of the first 13 terms would be 13 over 2 times 10 plus 46. And that would give us our sum. Let's change these values into a 13. And then we have 10 plus 46. And we get 364. So that's your 13th partial sum. Number 6, you can see the lower bound is 1, the upper bound is 42, which means we have 42 terms. If you put 1 into that formula, you get 2. You put 2 into that formula, you get 4. Put 3 in, you get 6. If you put 42 in, you get 84. So the sum of the first 42 terms of this arithmetic series would be 42 over 2 times 2 plus 84. And so if we go to the calculator on that, put in the right values, make that a 42 over 2, and then we have 2 plus 84. And that gives us a total of 1,806. And again, that's the 42nd partial sum. So that's some examples of arithmetic sequences and series.